Hi everyone, let's take a look at the following. Find the area of the region enclosed between the graphs of x minus y equal to 2 and y squared equal to x. Step number 1. By inspection, we're no longer thinking about top minus bottom. Instead, we're going to be thinking about right minus left. Now, the reason why we know this is because when you look at the second function, y squared equal to x, notice it's y squared. Y squared. And y squared means it's not a function of y in terms of x, where it's y to the power of 1. The moment you get y squared, this is telling you when we draw a graph, we're no longer taking the top minus the bottom. Instead, we're taking the left, or I mean the right, minus the left, just like that. And again, in case you're stuck, you're not really sure why this is the case, let's draw a diagram. Now, before we can graph x minus y equal to 2 and y squared equals to x, let's find the POI. So I will set up a little scale here so you can see what I'm doing. But I'm also going to graph both functions after. So again, if you want to find the POI, instead of saying y equals to y, we're going to write down x equals to x. On the right-hand side, x equals to y squared. On the left-hand side, again, here comes the mental math. If you isolate for x, x is going to be y plus 2. Again, just to be very clear, this came from the first graph. And the second part, y squared, came from the second graph, just like that. Now to solve this, all you have to do is bring it to one side, y squared minus y minus 2. This is simple factoring. Y squared becomes y times y. The factors of negative 2, that will give you a sum of negative 1 is going to be negative 2 plus 1. If you solve for y equals to 2 or y equals to negative 1. Really important, you find the location, not just the y component. So what you have to do is take this number, plug it back to either function. So I'm going to plug it back into x equal to y squared. Since y equals to 2, y squared is going to be 4. So x is going to be 4. And again, write down the location, 4, 2, which I'm going to label right here, 4, 2. Now, if you think about the second case, again, if y equals to negative 1, I take this number and I plug it back in to x equal to y squared. So in this case, x equals to brackets, negative 1, close the bracket square, negative 1 times negative 1, that's going to be 1. So again, the second POI is going to be 1, negative 1. I'm going to go back to the graph and add it just like that. Now, how do we graph both of these cases, right? If you think about x equal to y squared, it's going to look, roughly speaking, something like this. And again, the reason why this makes sense is because if you think about x equal to y squared, what you're really doing is the following, right? So I'll show some steps here. Y squared equals to x. The opposite of taking the square of y is to take the square root. So y really equals to plus and minus of root x. And again, if I want to be super clear here, this is the positive part of root x. And if I look at the bottom part here, negative root x, that's the bottom part just like that. So the combination, right, if I take all this away, is basically x is equal to y squared, which is this entire graph. And again, it is not a function because it fails the vertical line test. Now, in a different color, I'm going to graph y equal to x minus 2. Now, how do I know that? Because again, if I think about this, x minus y equals to 2. If I isolate for y, I bring negative y to the right, I bring 2 to the left. So y equals to x minus 2. This means it's going to be a straight line with a slope of 1 and a y-intercept of negative 2. So again, roughly speaking, it looks something like that. X minus y equals to 2. Now, let's go back to the first point. The first point we talked about at the beginning of this video is we cannot take top minus bottom. Now, why can't we take the top minus bottom? Because if we did take the top, which is right here, minus the bottom, it doesn't work. What do I mean? Think about the top function. This is the top function, which is x equal to y squared. But if you look at the bottom function, this blue part is x minus y equal to 2. This other orange part is going to be, the first part here, is x equal to y squared, and the second part here is x minus y equal to 2. So the bottom cannot be a combination of the two parts. So again, the short answer is you're thinking about right minus left. The right is this part right here, I'll call R, and that's going to be x minus y equal to 2. The left, it's going to be x equal to y squared. So again, here's how you set this up. That's right at the bottom here, so you can see all the steps. Your goal is to find this area. So area equals question mark. And A is the area, which equals to the integration of right minus left. So let's write down right minus left. And you're going to integrate this with respect to y. You're going to evaluate this from y equal to -1 all the way to y equal to 2. Let's break it down. So again, if you draw this line going across, y equals to -1. Likewise, if you draw this line going across, y equals to 2. And if you think about right, again, here's the right, which was x minus y equal to 2. And if you isolate for x, that's going to be y plus 2. So y plus 2, let's put this back. The bottom part is right here. And again, that is x equal to y squared. So if you isolate for x, that's going to be y squared, just like that. So again, the rest is extremely doable. You got this. First, you can copy everything and collect like terms. So y plus 2 minus y squared in brackets. Integrate this with respect to y. To find the antiderivative, the integration, this is going to be y squared plus 2y minus y to the power 3 divided by 3, evaluated from -1 to 2. Again, you're going to take the difference between the following. First, plug in 2. Minus in brackets, then you plug in -1. Don't forget all the brackets. Now at this point, again, you can take your calculator and work it out. I'm going to use mental math. Now before I keep going, I just noticed something. Let me go back one step. When I took the antiderivative of y, it's not y squared. It's y squared divided by 2. That was my mistake, everybody. Let me go back and edit this. Again, how do I know? Because I was double checking in my mind as I'm doing this live with you. When I take the derivative of y squared divided by 2, that's going to be 2y divided by 2, which is y. So now it makes more sense. So one more time, again, you can take the calculator. I'm going to go through mental math. 2 squared divided by 2, that's going to be 4 divided by 2, which is 2. 2 times 2 is going to be 4, minus 8 divided by 3. I'll put this in brackets, minus in brackets. That's going to be 1 divided by 2 minus 2 plus 1 over 3. If I collect like terms, that's going to be 2 plus 4, which is going to be 6 minus 8 over 3 minus, again, if I look at the terms here, it's going to be minus half plus 2 minus 1 over 3. And 6 plus 2 is going to be 8. Negative 8 over 3 minus 1 over 3 is negative 9 over 3. That's negative 3. Minus half. Here comes the final answer. Area equals to 8 minus 3 is 5. 5 minus half is 4.5. So 4.5. Or you can say 9 divided by 2 units square. I hope this makes sense.